In this video, we'll talk about the two types of linear equations that we haven't seen much of so far, and that would be horizontal and vertical lines. Believe it or not, their equations look like y equals a number and x equals a number. So just to recap on what most linear equations look like, they come in slope-intercept form. So that coefficient of x tells us the slope, which is that rate between point to point. So we learn that graphing is the direction from point to point. And then the constant is your y-intercept, or where to start. Sorry, you can probably hear my dog in the background. So if I'm looking at y equals 1/4 x minus 2, I know to start 2 below the origin. So down 2, and then use that slope of 1/4. Oh my gosh, which would be up 1 over 4. So from my starting point of -2, I'm going up 1 over 4, up 1 over 4. Then I would reverse and go the other way, down 1 over 4, down 1 over 4, and there would be my linear graph. Next up, I have the equation y equals -2x plus 5. Again, starting here, this time it's positive, so I'd go up off of the origin. And then my slope would be -2, which I can think of as -2 over 1. So down 2 over 1 each time until I run out of room, and then switch and go up 2. So that's what most linear equations look like, is that slope-intercept form. In this video, we're going to change things up. So the first weird type of equation we're going to look at is what it means when your equation only has y. So if we look at this, there's no y equals mx plus b. In fact, there's not even an x at all. It just says y equals 3. So what that means is in a table, y is always going to be equal to 3. And it's never going to change away from 3 because it's not dependent on x. So if we think about what that would look like as a graph, I'm going to take these and graph them as points. So my x value and my y value. So if x is -8, y is up at 3. If x is -4, y is still at 3. And just graphing each of these points. So we can see that if we were to connect these, we would get a flat horizontal line. If we think about the slope of that line, I'm going to use the table to help us. My change in y is nothing, where my change in x is kind of changing depending on what points you're looking at, but anything with 0 in the numerator is going to be equal to 0. So this y equals a number is going to be this horizontal line that has a slope of 0. By comparison, what if your equation only had an x? So this time we're going to look at if x was equal to 3. Same idea, x is always going to be 3 no matter what your y value is. So if we take a look at what that is as a graph, x would be 3, y would be -8, 3, -4, and now we can see it's a very different graph from the last time. This time we have this vertical line where x is always 3 and it's never moving left or right. So if we take a look at the slope, starting with my change in y and increasing by 4 and then by 2, but my x isn't changing at all. So my change in y over change in x would be some number over 0. And we learned that that is undefined. So if you have x equals a number, that's going to be this vertical line that has an undefined slope. So to help us remember which is which, there's this nifty little abbreviation that math teachers like to help us remember. So when you have a horizontal line, we like to remember it as HOI. And what that stands for is a horizontal line, a 0 slope, and y equals a number. So anytime you see y equals, so let's say y equals 3, I'm thinking a horizontal line at 3. So y equals a number, so again, this is y equals 3, means that it's not moving up or down from 3 at all, which is why it gives us that horizontal line. Then the next one to help us remember x equals is VUX, V-U-X, which stands for a vertical line, an undefined slope, and x equals a number. So let's say we had x equals 3. I would go over to 3, and I'm not moving left or right at all. X is always 3, never moving left or right. So it's a vertical line at that X value. So here's how you can use that Hoy and Vux to help you graph. Let's say we're graphing y equals 6. Well, when I see y and nothing else, that's that reminder that it's a horizontal line coming from Hoy. So I'm going to go up to 6 and not move up or down from 6 at all. So I'm staying in that horizontal line. In this next one, again, I only have y, so that horizontal line. This time it's negative, so I'm going to drop down to -4, but not move up or down from that at all. By comparison, if I look at an equation and I only see x, use that little reminder that that is a vertical line. So I'm going over to 5 and not moving over at all from there. So that vertical line at 5. Same thing if it's a negative. If I only have x, I'm going to move over to that value. So here, -3, and not move left or right at all unless you can't draw a straight line. So when you start to mix all of our linear equations up, what I recommend is first looking at the form of the equation. And the first thing you want to check is if you have both a y and an x value. If you do that, you know that that's going to be a diagonal line using your slope. If you don't, that's going to be one of those weirdos. So just a y value is going to be that horizontal line. Just an x value is going to be that vertical line. So looking at this first one, I have y equals 2x. And the first thing that I see is a y and an x. So that means I'm going to use the slope to help me graph. There's no y-intercept, or it's going to be a y-intercept of 0. And my slope here is 2 over 1. So up 2 and over 1, down 2, trying to do this quickly, and over 1. Again, anytime you have both a y and an x, it's going to be that diagonal. By comparison, the second one here is just a y, no x. So that's one of my weirdos to help me remember. Y goes with Hoy, so it's a horizontal line. So I'm going to go up to 4 and stay there. Let's do 2 more. Again, first thing I'm looking for is what type of equation I have. So here I just have an x, no y. So that's that reminder that that's a vertical line. So I'm going to move over to -3 and stay there. Next up in my equation, I have y equals 1/2 x minus 3. Again, right away I notice both a y and an x. So this is slope-intercept form, starting down at -3, using my slope of 1/2. So up 1 over 2 to finish off this graph. So again, I can't recommend it enough. If you're in charge of graphing an equation, really look at what format you have and seeing if it's going to be diagonal. Again, that would be both a y and an x, or one of our special cases. Just a y is horizontal, just an x is vertical. Good luck practicing.